In this lesson, we're going to talk about micrometers, often referred to as simply a mic, but not the kind that you speak into and record sound. This is the kind of mic we're referring to. So let's see. First question, should you close the spindle of your mic when storing it? Or should you leave it open, or does it matter? Let's talk about what that means.
So first I want to define what we mean by close. By close, do we mean bring that together?
Yes.
Touch?
Yep.
So
close it for me, and let's just... There it is.
Do you guys hear that click sound? Nice. Okay. So this is closing it. Should we close it before we store it? My assumption would be that yes, you want to close it so there's nothing that puts pressure on it. And I mean, I suppose that if there would be a rock in your toolbox and it gets stuck in there, maybe it could damage the perfectly planar or straight surface here.
Flat surface.
Flat surface. And yeah, just my instinct would be to close it. Is it important to close it?
It is important to not close it, actually.
Not close it.
Yeah. So intuitively, you might think that you want to close it, but what happens when you close it is because as you rotate this knob over here, it transmits some force. So you'll hear a click. There it is. All right, so this is a torque limiter, so you can't put too much torque on this, but you can put a little bit of torque. So what's happening right now is this spindle right here is placing a small force against this side, right? So effectively, it's trying to kind of pull apart. I mean, it's a very, very small force, but it's trying to pull apart this this U shape here. And if you store it like that, there could be some, again, these are really small, it's low risk, but still little residual stresses that kind of make their way down through the part and open this distance up a little bit erroneously. And so by storing it open just a little bit like that, you ensure that there's no stress in this interface when you store it. And that's really what you want to do, is make sure this is not stressed when it's stored.
I do want to ask you something about that we recently learned in a previous learning objective, which is yield strength. So if the yield strength of this material here, if you put it under pressure and close it and leave it stored, when you remove the pressure by opening the caliper, the mics, wouldn't this go back to the natural state?
Absolutely. Yep. In theory, that is true. And so probably it's not going to hurt anything, but it's definitely not going to hurt anything if you leave it open just a little bit. So it's best practice to leave it open just a little bit.
Did someone give you that advice, or how do you know?
It's common knowledge amongst engineers that you shouldn't store calipers closed like that.
Mics.
I'm sorry, mic. Yeah, so a caliper here, it's fine to store a caliper like this because when you close it, there's no residual stress. You're not putting a force or any kind of load here. But with a mic, especially since it is such a delicate precision instrument, you don't want to load it up unnecessarily, and certainly you don't want to store it in a loaded state, just because it could cause some kind of little stress or damage to the instrument, and there's no reason to do that, you know.
Sounds good. Okay, next one.
All right, how thin is 500,000ths of an inch, or 50 millionths of an inch? Same thing. Put this in practical terms by comparing it to something thin, for which most people already have the appropriate context.
I'm guessing, I have no idea, but I'm guessing that's like the thickness of a hair of your eyelash.
Yeah, so let's see. The human hair is, I think it's a few thousandths of an inch. A few thousandths of an inch. So if we're talking about 500,000ths of an inch, let's see. Can we just pull up notes here? So let's say that human hair is 2,000ths of an inch, something like that. And we're talking about, what was it, 500,000ths of an inch?
How thin is 500,000ths?
Okay, so 500,000ths of an inch. This is 1, 2, 3 is thousandths of an inch. We're going to be 10,000ths, 100,000ths of an inch. So 0.002 divided by 0.000, hold on, 500,000ths of an inch. What is that? What is that? I guess that's, oops,
15 millionths of an inch.
right there. I think that's 500,000ths of an inch. So many decimal places. That's not a common decimal place that we work with.
No one's going to ask you to build a part with that precision.
No. And if they did, you'd have to tell them no, because it's basically impossible. All right. So let's do...
How thin is 500,000ths of an inch?
0.002 divided by 0.00005. That's where we were, right? Yeah, okay. So that is a 40th of human hair. In other words, if you split a hair into 40 equal distances, that would be 500,000ths of an inch. So it's really, 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 really small.
So that is how precise a mic is?
Yep, that's how precise that mic is.
When do you ever need to go down to that? You just said that a customer's generally not going to come to you. Has a customer ever come to you with that level of precision?
Occasionally, yeah. And really, the digit that you're most concerned with is this one, 10,000ths of an inch. And certainly there are applications where you need to measure down to 10,000ths of an inch. This last digit here, actually on a mic, and just like the fourth digit on a calipers, the fifth digit on a mic only gives you resolution of 5, 0 or 5. So this last digit is never going to be 1 or 2 or 3 or 4. It's always going to be 0 or 5. So you have limited resolution there. But this fourth digit, you have full resolution on a mic, whereas on a caliper, this fourth digit, you only have 0 or 5 resolution. And that fourth digit is 10,000ths of an inch, and certainly there are applications, like, for example, if you wanted to press fit a shaft into a ball bearing, into the inner race of a ball bearing or something like that, you would want to be able to measure down to 10,000ths of an inch. Sometimes when measuring like really thin films, you'll also want to have that kind of resolution. Yeah, those are some.
When you set the origin for this, you mentioned that for the calipers, you always want to set the origin before you get started. You do that here too, right?
I do, yep.
Do you wait for it to click and then set the origin, or prior to the click?
So a point of clarification there. I rarely reset the origin, but I always check that when the mic or the calipers are closed, it reads 0.
Closed and clicked.
Closed and clicked, yep. And if it doesn't read 0, then I would reset the origin. But that rarely happens. It's very uncommon for your mic or your caliper to simply drift out of 0 on its own.
So you use the mics for dowel pins usually, is that right?
I wouldn't say usually, but that's certainly one situation where you could use a mic.
Okay. Sounds good.
Okay.
Force.
If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.